Did you say go?
Yes.
Okay, all right, here we go. Good afternoon, everyone. We are Team Null, and our project is the SEC betting model. My name is Matthew, and without further ado, let's go ahead and get started.
That is the wrong computer.
So for stand-ups, due to all of the social distancing stuff that's happened, we've done pretty much everything remotely. We meet pretty much every day of the week, during the week, Monday through Friday. And so on Monday, Wednesday, Friday, we do 2 to 5. And on Tuesday, Thursday, we normally do 4 to 7 due to classes. Go ahead.
Here is our burn down chart. Our estimated velocity was 67 points. And at the end of Sprint 3, we completed 54 of those points. If you look at the burn down graph, you can go back one. You can see a plateau between days 4 and 7, and that's due to us just adjusting to online course material. Here is our burn up chart. You can see that we didn't complete all of our points that we had set aside. The only thing we had left was 13 points, and that'll be explained later in the PowerPoint presentation.
So as Travis mentioned, we completed 54 points on our Trello board, as you can see on the left, and then our 13 points that are left out are shown on the right. We had to cancel them due to the fact that we had some trouble working with SSL certificates for sign-in, and that's why they got canceled. So as you can see here, we had a total of 8 new Git commits this sprint, with 5 of them being meaningful commits. Some documentation and things like that. And then a few of the pushes were just housekeeping.
All right, as far as security, last sprint we already did password hashing, so that's a goal that we actually completed a little bit early because we had a little bit of extra time on our hands last sprint. But this sprint, we were mainly focused on SSL certificates and login tokens. We canceled SSL certificates because of the way to get it verified. So with SSL certificates, you pretty much have to go through a lengthy process to get it approved by all the browsers corporations, and so that they can trust that in-house certificate, or you would have to pay for it. So we didn't want to do kind of either of that, so we just scrapped it and decided to do login tokens instead. And so this sprint, we implemented 1024 length random character login tokens.
And for lessons learned this sprint, from code, we learned that Angular does not work well for us with working with Express with our APIs. So we switched over to React. That was part of this sprint, was getting that all up and running, and that's how we were able to do some of our security things, or advance our security things. So a lesson learned from that was picking our correct stack can sometimes take time or multiple tries. Some lessons we learned from the group, since we're all online now, screen sharing has become very important to us. That way we can look upon other people's code and help them debug things. And then we also learned that some group members are very productive at different times than all of us. Adjustments we want to make for next sprint is maintain online communication. Since we are all online now, we are trying to make sure we have set times and we know who's going to be there and who's not going to be there, so we can plan accordingly. Other things we want to do is balance our workload. Again, all online now, we need to make sure we all have roughly the same amount of points. We need to make sure our Git commits are spread out evenly. As you saw earlier, there was very few this sprint, and that will be explained why in a little bit, but mostly it was because we were doing more research than actual coding this week. And then as well, for workload, we need to make sure we stick to it and aren't switching story cards or points. Now, before the demo, we actually want to talk about the model and the research we did for this sprint. A lot of this sprint was looking into how to build a model and what data we need for the model.
So when it comes to the model, our primary source of research was a paper from the University of New Hampshire in Durham. What they did was they predicted the outcome of NFL games using logistic regression. and that got us on the idea of using logistic regression for our model that we'll be using. But the difference between what we're doing and what they did for their paper is we are looking at college conferences rather than the NFL. And then moving on to the equations that we use, on the left hand side, you can see the equations that are pulled directly from the paper. And then on the right hand side, you can see the modifications that we used. One of the biggest things that we were trying to do was have the probability reflect a comparison between team A and team B. Can you go back just 1 second?
Sorry.
All right, so on the right hand side for the new equation, we have the probability of team A winning over team B is equal to 1 over 1 plus e to the negative u, where u is equal to our weights multiplied by the difference of the two attributes of the two teams. And then below it, you can see a graph that this function has a range of negative infinity to infinity, where its domain is linked between 0 and 1. You can move on.
So, diving into our uses for the actual models and all, depending on the model, we could either reduce our data or select our data. We could reduce our data through the weights of the given attributes on a per year basis, as our data was from 2005 to 2018. Now, in our three ways of selection, two of which we have implemented so far, the correlation matrix is basically a table showing all the correlation coefficients between all the variables, as you can see right here. And then the other one we have implemented is the backwards elimination, to where all the independent variables are entered into the equation first, and each one of them is deleted one at a time if they do not contribute towards the regression equation. Our last one was the recursive feature elimination, based on the idea of repeatedly constructing a model and choosing either the best or worst performing feature, and repeating the process with the rest of the features.
One more note for this slide is this selection process is how we'll determine the beta values for the equation in the slide before.
All right, and for our demo, so today I'm going to show our front end that is done in React and is hosted live. So if any of you who are watching this want to go out, I'll show the. So first thing is I'm going to show our front end, which is currently live. Let me go to it. So it is at 138.47.204.57:3000. So you can put this in any browser and it should work. I'm going to show registering, so I'll do my name, last name. I'm going to do some random email, and I'll choose a password. And it says successful sign up, and so then I'll go over to email. I'll type the wrong thing. You'll say, hey, that email isn't with our system. I'll do the actual email, but the incorrect password. And it'll say, hey, you logged in, but that's not the right password. And then I'll do the correct password, and it'll let us log in. So that's what we have so far. Our front end's a little bit behind, but that's okay. We've had to switch front ends in this past sprint, so we're trying to catch up a little bit. But I really wanted to show today what our tokens are all about. So again, like we said earlier, our token we have basically 100,000 tokens, all of which have 1,024 random characters. And essentially every time you log into the website, you essentially check it out, or like check out the token. And then when you log off, that token can no longer be used ever again. We can check that, we can verify that it's still you using it because we verified the IP address of the person logging into our system, and we write that down in our database. So I'm going to go ahead and create the tokens. It's going to take a little bit because it has to write 100,000 lines of code to a text document and then connect to a database remotely, and then that's it submitting all of the tokens, all 100,000 of it, to our database. So it's just going to take a second. So if we go over here and look at it, this is our current tokens, what's in our database. As you can see, we have tokens, whether or not it's checked in or out, which is a Boolean true false, and then the IP address if someone connects. So I will show an example of this in action. So this is Postman, what we do, the software that we use to check all our APIs. And so I'll log in with something that I know exists. We send it, it returns back our login token, and then if we go back and check our database, we can see that this token, which is, I guess, a bunch of zeros and an O, I think that's the O. And then this is the rest of the token. We can see we receive that as returning back from the API. We also have it checked out that, hey, this token has been checked out, and we also have the IP address of the person who checked it out. And if we send it again, we log in again, we can see we get a completely different token. That token has been checked out and can no longer be used, but this one can currently be used. And so yeah, that's what we have so far.